I greatly appreciate your attending today's conference. Feel free to contact me directly at darby@delphon.com with any questions. Today, I will be addressing a common issue prevalent in the packaging, shipping, and handling of thin semiconductor devices in the microelectronics industry. BAE Systems, a long-standing gel pack customer, approached us about a costly issue they were experiencing where thin, high-value devices using microwave modules and other microelectronic assemblies migrate out of the pockets of standard waffle pack trays received from their suppliers. This die migration issue, which we have termed as COOP, component out of pocket, is a significant cost driver in manufacturing operations and results in the following conditions: component damage and scrap, non-value added labor to inspect and reposition components in the tray, production interruptions, quality management system administration labor, and decreased pick-and-place machine utilization. COOP is simply incompatible with automated assembly, and every attempt to prevent it should be made. BAE was confident that GelPack, backed by Delphon's material and manufacturing expertise, could collaborate with them to solve this serious problem and drive towards a zero-defect shipping solution. Here we show an example of the costly COOP problem BAE was experiencing. The two left pictures show X-ray images of small, thin die that have migrated out of their pockets during shipping and handling. The image on the right simply shows what COOP can look like once the lid is removed. Oftentimes, COOP is thought only to occur. PA conducted an extensive study into the root cause associated with component out-of-pocket defects and identified. If you review the data sheets for industry standard waffle pack trays, they indicate that carbon-loaded polypropylene material has an upper specification flatness tolerance of 12 mils for both the individual lid and the base tray, which means there is a potential for up to 24 mils of total warpage, creating a gap from which components can easily migrate. ABS and polycarbonate materials have a much tighter flatness tolerance of only 4 mils for the tray and lid. While this equates to an 8 mil gap, this still is more than enough room for a thin die to escape. To quantify this issue, BAE measured the flatness tolerances of several waffle pack trays using a Keyence R3200 3D scanner. The red and orange colors show the high spots where the blue shows the low spots. In this case, demonstrating a 9.4 mil gap between outer locations A and C, thus allowing components to migrate within the blue interior location, the heart of where the devices reside in a waffle pack. Inserts such as Tyvek have been used with waffle packs for decades. Few of us know their real function, and many assume they exist to prevent devices from migrating, but we will show you that is not the case. The true intended function is to create a softer surface for sensitive components during shipment, so inserts are not intended to prevent COOP. Furthermore, using inserts is a tedious and near impossible installation process that requires operators to precisely align the inserts when placing the lid on the tray. If not done correctly, the insert will be pinched by the edge of the tray, which creates a path for die migration. There is no doubt that assembling waffle packs with loose inserts is a source of COOP. Another contributor to COOP is the standard one-piece clip itself. The insertion and removal of a tray and lid from the clip is subject to human error, as the mechanics are not consistent from operator to operator. Compounding the problem is the fact that the basic design results in uneven bending stresses across the tray and lid, which can magnify the warpage issue and increase potential die migration. We've also found that when clips are reused, the springs can become worn, thus exerting inconsistent holding forces. So, what are the exact design requirements for a new product that can virtually eliminate component out of pocket, or COOP as we call it? The lid must be able to uniformly seal each individual tray pocket. Product must compensate for waffle pack tray and lid warpage issues. Lid and clip must be compatible with existing pick and place equipment. Must only use static, dissipative, low outgassing, non-silicone, FOD-free materials that are prevalent in the semiconductor industry. And finally, have a proven methodology to validate that the solution works. Our solution, a new patented lid clip super system, which we refer to as LCS2, was engineered to pair with industry standard waffle pack chip trays to fill each and every tray pocket and establish a new industry best practice for COOP-free thin device shipping and handling. LCS2 is an enhanced lid comprised of a low alkalizing polyurethane foam and industry-approved interleaf material assembled onto a static dissipative injection molded lid using silicon-free pressure-sensitive adhesive. A huge added benefit of this design is that operators will no longer need to manually position clumsy inserts in the waffle packs. The lid is then combined with a novel clip design that uniformly compresses the lid against the waffle pack, ensuring intimate contact of the entire interleaf against any warped waffle tray surface. This new clip contacts the top surface of the lid, not the outer edge like standard one-piece clips. You will note the unique goldish color of both the lid and clip to denote the ESD Class 000 protection provided by this LCS2 solution. Another feature of this new clip is that product labels can be safely applied to both the lid and underside of the tray while the clip is in place, thus avoiding any handling-induced COOP. The opening in the bottom of the clip also provides easy scanning of the tray barcode labels while the clip is still in place. Here's another view of the overall LCS2 product and how easily it works with a standard waffle pack tray. The LCS2 Performance has been validated by BAE Systems via rigorous 34-inch drop testing of 50-micron GaN die loaded into StatPro 500 chip Sentry trays. Using X-ray imaging, zero COOP was observed after 100 total drop tests using the LCS2 Super System. In comparison, when conducting the same drop test using the industry standard waffle pack solution, significant COOP was detected. Overall, this novel lid clip super system solves for the costly component out-of-pocket condition for thin compound semi-components 250 micron or less. LCS2 has been tremendous potential to curb millions of dollars in waste and improve component process efficiencies worldwide. This new patented LCS2 solution is supplied exclusively by Gelpack, a division of Delphon. I greatly appreciate your attending today's conference. Feel free to contact me directly at darby@delphon.com with any questions.